Hello everybody. For today I need you to follow along on your screens with me. As I just asked you, I need you to open up Bridge Designer 2016 on your desktop. When you do, you will see this window. We are going to select Load a Sample Bridge Design. Since today is your introduction to the Bridge Designer software, we're going to load a sample bridge so we can see what we need to do. So please click Load a Sample Bridge and click OK. You'll see that there is a vast list of options to choose from. To start with, we're going to choose the Warren Through Truss with a 20-meter span. So go ahead and select the Warren Through Truss and click OK. As you'll see, we have our landscape here with our bridge. It has the abutments on the side of the river, and it has labeled some things for us. So there's the floor beam, which is the beam that runs across the bottom of the bridge. There is a concrete deck, which is the actual decking material that holds up the road, that is the base of the road, and then the asphalt road surface, which is what your cars actually drive on. You'll notice over here on the right there is a box with lots of the columns and the rows, and all of these components are parts of the bridge. So if we select our select tool and click on one, you can see that that is piece 7. Then it gives you the slenderness of those pieces, it gives you the length of all the pieces, and the size in millimeters for the dimensions, for the thickness. So the first thing we need to do is test this design to see its effectiveness. So up top, we see this light blue box with a triangle and ruler. That is our drawing board. We're going to go right next to that and click the teal button, which is the test. We'll see an animation that shows the bridge kind of pink and blue as the truck drives over it. Pink are compression forces where the bridge is being squeezed together. The blue are tension forces where it's being pulled apart. And as you can see, the truck drives over it very well and the bridge holds up. Now we're going to go back to our drawing board, and you'll see over here on the right hand side these numbers. So 0 point what have you, okay? Our goal is to be able to design a bridge that still holds up but is as cheap as possible. So we want these numbers to be as close to 0.9 as possible. So what we need to do is come over here, make sure we're on the tool, the selector. We're going to click up above to the left of the bridge and drag the box so we select all of the pieces. You'll know that because it'll turn blue here and it'll all be blue here. What we're going to do is, you see, we can change these drop downs. We have carbon steel, high strength, low alloy, or quench tempered. We're going to leave it on carbon steel for now. We also see in the middle we have solid bar or hollow tube. Again, leave it on solid. What we are going to do though is change the thickness here. We're at 160. We're going to start just one piece at a time, drop it down to 150 millimeters. And we're going to go ahead and test it and see if the bridge survives. We notice it's already a bit more pink and blue. It does survive. So let's go back to the drawing board, and we can see over here we went from 0.2 as the highest, and now we have a 0.4 for compression, and a 0.23 is our high for tension. So again, we're going to select. Let's drop it down to 140 and test it. You can see already it's under a bit more compression force. Really gets dark pink there. So again, we check our measurements on the drawing board. We're at 0.48, so we're almost halfway. So let's skip a couple here, go to 120 and test it. And you'll see that it's already under pretty heavy compression on the screen. Gets very dark red. That looked pretty good. As we can see on our data over here, we are at 0.78 and 0.76 is kind of our normals for compression, and 0.35 for tension. So let's try one more drop down to see if the bridge can hold it. And you'll notice our price, we're at $214,238. When we started, we were at $287. So let's drop down to 110. And test it. We'll see it's already again under considerable compression and tension. And here you see the bridge collapsed at that piece. When we go back to the drawing board, it'll point out which two pieces failed, 8 and 9, as they were at 1.05 and 1.03 levels of force for compression, which is not sustainable. 1.0 is the failure. Okay, that's 100% compression plus, so they could not survive. Once we've done that, so we know then that the 120 should survive as it just did before. So it just survives. So we know that our cheapest price at this level for these materials is $226,000, $226,772.79. If we click on our calculator, we'll see that the material cost for the steel bar times all the material, just the cost of steel, is $78,472 and change. The joint cost, so the connections, is $8,800. The product cost for the bar just to be made is $1,000. The site cost, so for the decking of the road material, is $23,500. The excavation cost, which is to dig out this material to build in the bridge, will be $106,500. The abutment cost, which is to put these concrete abutments into the ground and anchor them, is $8,500. Pier cost is $0 because we don't have any pier in the middle and we have no cable anchorages. So that's how you get our total cost of the bridge is $226,772.79. Now the challenge is to change one of these bits at a time here. So we're going to try a high strength, low alloy steel, keeping solid bar, keeping the same size. You see the price jumped up to $250,000 for it, and almost $250,500, just shy. So we're going to test it here. And you see already there's some compression, but it survives. As we check our data, come over here, we're at 0.7 is our highest. So we're going to try to lower that to 110. See, we're at 234,000. We'll try this out. And here again, we fail at the same spot. Okay, so let's go back. Let's try, since it gets to the same basic spot and it costs more, we're going to try something different. We're going to try a hollow tube. We're going to try up at 140 just to see. Hollow, you can see it's already going to compress and it's going to break. Okay, but you also notice it's only $181,000. Now you see on that particular run, we lost 5 pieces that were well over 1.0. So we're going to make this a little bit thicker. So hollow tube, alloy steel, 170 millimeters. Okay, the bridge is a bit thicker. It's got a lot of parts. It underwent a lot of stress there. So we'll check. This is about as good as we are going to get on this particular bridge. We were at 0.97, 0.96 for compression on those center pieces. So if you click on that, that is 8 and 9 are at the 0.97 and 0.96. Okay, you can do options where if you click on, say, just this outside and you hold control down and click, you can choose just individual beams. Say if you wanted to bump those up to 180, make them a little bit stronger, and you could test what that would do to the rest of the bridge. The problem is when you increase certain pieces, it adds stress to the remaining. So you see how the tension got a lot more on the bottom of the bridge while the compression was lessened. So if we check our numbers now on our tension, the numbers are a lot higher at 0.67 and 0.57 than they were, but that bridge still works at $197,000. Alright, so something you could try. I want you to experiment with the different materials, hollow versus solid, and come up with the cheapest bridge. When you do find your cheapest, most successful bridge, I need you to go to File, and you're going to print your bridge. It'll take a little while for it to load up. You pick the correct printer and then you hit print. It will give you a print off of your bridge design and your materials list, and the cost will be on there as well. I look forward to seeing your bridges work, and I'll give you time to stop. Thank you.